useful tool. All right, double checking the recorder. Okay, it is on the right channel. All right, so first thing first, let me fix the, okay, this is the wrong class. But it does bring up, something interesting. If you're really interested, another wrong class. If you're interested in computer security, I strongly recommend that you spend some time to take at least 1 or 2 programming classes. You will find that programming classes can be quite useful in terms of making computers more secure. For one thing, you can write a program to kind of automate a process to assess the security level of a particular system. That's for one thing. And then the second thing is, where do you think these security problems come from, or most of it?
Malware.
Okay, malware. Okay. There are several things you can look at. When you look at it from the perspective of malware, do you think malware just comes out of existence on its own? No, somebody has to program. Yep. So that's why programming can be helpful, because you can actually look at the detail of a malware program and figure out how it works. What about patches? Yep.
May we ask which programming course do you recommend, Professor?
To start with, I would recommend ciss342. That's it's called Algorithm Design and Problem Solving, or ciss340, which is Visual Basic. Those classes are really good, as beginning classes. It will get you familiarized with the basic concepts of programming. So I would start with those particular classes.
CISP 100?
Yeah, CISP 300. All right, so I'm going to change the settings for the permissions and ownerships and permissions quiz, so that I'm removing the restriction. So this way you guys can get started right away and does not depend on the previous homework assignment. Save and display. Right, so that should be good.
Attempts.
Well, one person has attempted already. That could be me.
Oh.
When I was testing it. All right. The last question of the of ownership and permissions was, what if you don't have the cooperation of a root user? In other words, you're dealing with you have your files and your account on a computer system where you are not the administrator, okay? And the administrator says, okay, we cannot change, group ownerships. In other words, I cannot add additional users to a particular group. So the question is, how do you share files and still be sure that only people that you intend to share the file with can see your files? Okay, that was the question. As you go through this particular homework assignment, what you will see is, I will give you the instructions as well as the theory of how to protect your folder or your directory, home directory, from other users. Okay, so you can lock it down, not a problem. Okay, to lock down a folder, you do not need root permission. However, if you have certain files to share only with certain users in the system, now you have a problem, because that traditionally you can set up a group and then add people to a group, add membership to the group, so that certain people have group membership so they can see your files. Okay, but to do that, to add people to a group, you need to have root permission. So what if you are using a system where you do not have root permissions and the root user, the administrator, just refuse to do anything like that? Okay, well, that's why I changed the order a little bit. So this time I'm changing the order to introduce GPG ahead of all the other topics. It's pretty much independent. I mean, it's not really dependent on other topics. So moving GPG up is okay. I mean, it's not going to be a big problem. All right. So we'll start with this particular module, okay, to talk about file-based encryption using this tool called GPG. Are there any questions about encryption in general before we get started, or any particular point, anything that you guys specifically want to understand as far as encryption is concerned? Yep, go ahead.
Actually, I found that when I reinstalled my OS recently, I found that good to use encrypt.fs, and actually it encrypts your home directory via by the login session.
Okay.
If you log out as a user, it actually will re-encrypt wouldn't that be somewhat more secure than if you did the mounting via the slash partition and then
Yeah.
if it's running, then all the other users can still actually
Interesting.
Into the other user.
Do you have to install a specific module for that?
Oh no, it was by default.
By default.
Yeah.
And which distribution are you using?
It's 1204.
Ubuntu?
Yeah.
Interesting.
Because I thought that was like one. And maybe it's not secure in general, but like it uses a different mechanism. So
Okay.
it's
Well,
not
I'm going to look it up because that's interesting. So you're basically saying, when you sign in, it will use your sign-in password to decrypt
the home
files related to you
At least
only.
that's my understanding of how they do it. I
Okay.
was reading up on
But
it.
when you sign out, then it will,
I guess I could test it.
re-encrypt it.
Yeah.
Okay. Well, I'll go over this first, but I'll keep that in mind, and I'll look it up. So next time, if I find anything useful, I'll share that with the class. But thank you for sharing.
Oh, and I also had a question.
Yep.
Would it be more secure to use, to shut down probably more, but I sleep, keep your computer on sleep or hibernate. It's probably more secure to shut it down than it is to use like a lock screen or.
If you have an encrypted partition, I would definitely say, if you shut it down completely, it will be more secure. Even if you hibernate, it will still be more secure to hibernate, because when you wake up from a hibernation, it's the same thing as power up. It still has to ask you for the encryption key for your partition in order to resume the execution. Now that's a very good question, because if you do anything like that, do any type of suspension or hibernation, you also want your swap partition to be encrypted.
Yeah.
Yeah, because otherwise, if your swap partition is not encrypted, then someone else can use a live distribution, boot up your system, and then go through your entire swap partition, and you have a lot of stuff cached in the swap partition potentially. Yep. So that's interesting. That's a good point. All right. Any other questions before we get into GPG for file-based encryption? If there are no questions, we'll go ahead and get started with section 2 of GPG. GPG stands for GNU Privacy Guard, and yes, you're definitely right. This is a play of name, because there's another product called PGP. Does anyone know what PGP stands for?
Pretty good.
Protect privacy or protection. Pretty good privacy. I would assume it's privacy. Okay, but GPG stands for GNU Privacy Guard, and it's definitely a play of the name, PGP. So they just inverted the position of the P and the G, and make it, Oh, okay, there we go. Okay. The answer is on the whiteboard. Tag, it's open book, open notes. All right. So this is basically a free replacement of PGP, and PGP is a commercial product, or at least at the time I wrote this, it was a commercial product. Whether it still is a commercial product or not, I do not know. To install GPG on a Debian-based system, use the following command: aptitude install GNU PG. Okay, not the package name is not GPG, but GNU PG, GNU Privacy Guard. You can also optionally install the documentation package using the following, which is not automatically installed when you install GNU PG, so this is a separate package. Are there any questions at this point regarding how to install it? No questions? Okay, the installation part is easy. You do need root permission to do it. So if you're using the virtual machine that we have been using for homework assignments, you have to switch user to root first, and then you can run aptitude to install additional packages. The next slide talks about key pair encryption in general. Okay, so this one is not specific to GPG. It applies to key pair encryption in general as a encryption strategy. Key pair encryption is also used for a lot of things. SSL, for instance, uses key pair encryption. SSH can also use use key pair encryption. So what exactly is key pair encryption? Now, I can read all this stuff here, and most people will just kind of fall asleep. So instead of reading it, I'm just going to use a demonstration. Unfortunately, I only bring one key fob today, so I'm going to have another big keychain here as my prop. So let's say with key pair encryption, as the name implies, keys come in pairs. Okay, So we are not dealing with a single key, we're dealing with a pair of keys. So when the keys are issued, they are issued in pairs. Are we doing okay so far with that concept? Okay. So let's say, I'm just picking out, one key here. Just picking out this key here and this key, and I call this a pair. Okay, so when they're generated, they were generated as a pair. The interesting thing is, now this is not normal, okay? When you lock up stuff, in a normal sense, whatever key you use to lock, to basically, to turn a lock, it's the same key that unlocks, the very same lock. Is that making any sense? Okay. But in key pair encryption, it's not like that, okay? If you use one key out of a pair to lock up something, you have to use the other key of the pair to unlock something. But the relationship is symmetric, which means you can use this one to lock something and then use this one to unlock something, or you can flip it. You can use this one to lock up something and then use the other one to unlock something. Now that property comes in very handy sometimes, okay? Now out of the two keys out of a pair, what you need to do is to designate one as a private key, which means don't let anyone have possession of that key, okay? That is yours. And then the other one is called a public key. A public key, as the name implies, can be public. You can post it on a web page. You can post it on Facebook. You can put it, somewhere where everybody can see it. That's why it's called a public key. Okay? All right, so let's see how it works. The way it works is when people want to send you information and you want the transmission of the content to be protected by encryption, what they will have to do for people who want to send you information is to get your public key. So let's say this is my public key. So what they would do is they would encrypt the content using the public key, and then they would transmit that over media that is not secure. In other words, let's say Vincent here is a recipient, and I want to send him something. Okay, let's say I want to send him his grades, and I don't want anybody else to have access to his grade for student privacy. Okay. And the first thing I would do is to get Vincent's public key. So he will have to give me his public key, not my. This has nothing to do with me. Okay. So Vincent will have to give me his public key, and that can be done by he can post it, on the website. Okay. He can post it on a website. He can, use Facebook and say, okay, here's my public key. Use it when you want to send me, in secret. Okay. So I take his public key and I use, the appropriate software. And then I use a spreadsheet, to compute his grade, and then I would use, GPG and Vincent's public key to encrypt that file into the encrypted form. Are we doing okay so far? Okay. So the encrypted form, let's say, this is the encrypted, document here. All right. The encrypted document, I can put it anywhere. I don't have to, give it to him, give it to Vincent in secret. I can post this on the internet for everybody to see. Hold on a second here. We are letting the public key on the internet. Everybody can see that. We have the document that is encrypted by the public key also for everybody to see. But doesn't that mean everybody can now unlock the document and see the content? No, because remember, when you lock up something using the public key, you can only decipher it using the private key, the other key, which is not published. That key, Vincent will guard with his life, or close to. Okay? So now, all I have to do is to post that document on the internet, and then I send an email, which doesn't have to be encrypted, and tell Vincent, the document is over here. And then Vincent, having the private key, can download the document, and then decipher it, and then get to the actual content of the original document. Is that making any sense? Sort of? Okay. So this is a really cool way because there's only one component that needs to be protected, which is the private key. Everything else, the document, the encrypted document, and the public key, I can distribute it any way I want. There's no concern about too many people knowing it. Are there any questions about this? Okay. So that's basically what this slide is talking about, is how key pair encryption works. One key locks, the other key unlocks, but the relationship is symmetric. Okay. But there's another issue. The other issue is Vincent is not convinced that I actually am I am the person who posted his grade, and I'm the person who sent him the email. How difficult would it be to spoof email from somebody else? It's easy, right? It's very easy, extremely easy. Okay, so when you receive an email, of someone that you seem to know, telling you that, oh, you have just won, $2 million, meet me here, and I'll give you the money. How do you know that is real? You can use certificates. Okay, so the question now, is how do certificates work? How can you do not encryption in this case, but authentication using key pair encryption? Okay, so let's go ahead and take a look at that particular concept. In other words, key pair encryption is useful for two main purposes. One is for encryption, so that you can transmit something over open media that everybody can see, but only the intended recipient can decipher the content and actually get to the content. But the second purpose of key pair encryption is for authentication. In other words, how do you make sure that this email did come from that particular person, right? So let's use the same scenario as last time. Okay, I'm the person who is supposed to send Vincent his grade, and Vincent is not convinced that I am who I really am. So how do I make sure that Vincent is convinced that I am tech, in fact, and I'm sending you the grade? Okay, and the way it works is, in this case, I would have to give Vincent my public key. Okay, so I would basically say, world, this is my public key, and Vincent, this is my public key too. You make a copy of that. Okay, I'm holding on to my private key. All right, so I think just talking about it is going to be a little bit confusing in this case, so I'm going to write down the exact steps. Okay, all right. Okay, so we have person A being the sender, person B being the recipient of an email. Okay, so there are two parties. Party A is sending, party B is the one that is receiving. Okay. A publishes a public key. B gets the public key either by any means possible, because it's a public key, so you can freely distribute a public key, not a problem. And then what happens is A is going to composes a email message. Okay. The email message itself, unless the content needs to be encrypted, it's okay not to. It's okay not to encrypt it. In other words, if the content is really just saying, "Hey, Vincent, your grade is now available. Go to this website," and the encrypted document is over there. There's nothing to really encrypt, because there's no secret in the message itself. So I'm not going to encrypt this message in this case. The next thing is to compute a quote-unquote digest from the email message. What exactly is a digest? Checksum, MD5. It's basically a long sequence of bits that is computed from a document based on a known algorithm. Is there any big secret here how to compute MP5 checksum from a document? Is the algorithm known? Does it depend on any secret keys and whatnot? No. So it really is just a way to summarize a document and say, well, you know what? I'm pretty sure that most other documents cannot create a digest like this one. Okay. Does it mean that it is not possible? Not really. Okay, because if you think about it, there can be other documents that can generate exactly the same MD5 checksum. It's just very, very unlikely that another document, that is also legible, readable in English, will give you the same MD5 checksum. So it's kind of like a signature. Okay. All right. So the digest is computed. Okay, I'm just going to emphasize here, there is no secret in the algorithm to compute the digest. Okay, so there's no big secret here. It's everything is well known. Okay, the next step seems to be kind of strange, because what will happen here is A will use A's private key to encrypt the digest. All right? So not only do I have the original email message, not only do I have a digest, I don't want to publish the digest itself. I'm going to send a encrypted digest using my private key as an attachment, to when I send the email to Vincent. And we're doing okay so far. So whatever I send to Vincent has the original message and also an encrypted digest. Okay. A sends B the email body and the encrypted digest. All right. B receives the email. Okay. So Vincent received the email. The email itself is not encrypted. It can be encrypted if I want it to be, but there's no need in this case. And Vincent is thinking, well, did tech really send this email? Wait, hold on a second here. There's an encrypted digest. Okay. So what happens is, when after B received the email, B will have to compute the digest of the body of the email. So Vincent is going to use his own computer using the MD5 algorithm and say, well, the digest of this particular message is supposed to be ABCDEF. Okay, whatever the bit pattern is for ABCDEF. Okay, well, that part is easy to do. Anyone can do that computation. But now the question is, does the signature match ABCDEF? Okay, so now B uses A's public key to decrypt or decipher the encrypted digest. Okay. In other words, Vincent is going to use my public key to decrypt the encrypted digest. So that digest, which is decrypted, should match the actual digest of the body of the message. If they do not match, then we have a problem. If they match, then assuming Vincent can be sure that the public key that he's getting is actually my public key, then the authentication part is done. Are we doing okay so far with that concept?
Is that the same mechanism that's used in checksums?
MD5 itself is a checksum, but this is not just checksum, which is basically just making sure that you're not losing any content or the transmission did not introduce any accidental errors. This is for authentication, which means we are authenticating that this message did come from the so-claimed sender. So in this case, I did send the message to Vincent. So it's not really just making sure that there's nothing lost during the transmission, but it's also making sure that the sender is the sender. Now, how can go ahead?
So if someone else's private key originally encrypted it, would it make a checksum that doesn't match, or do you get some sort of error that says these two keys don't match?
It will not match. It will still give you something. It will still give you something, but it won't match anymore. Okay, but that's really cool because it is still based on key pair encryption, except in the case of authentication, the sender's public key needs to be known to the recipient, as opposed to encrypting the content, where the receiver's public key has to be known by the transmitter. Is that okay so far? Now, how can Vincent know my actual public key? Because if I send him the public key in a separate email, that's useless, right? Because for exactly the same reason, the first email can be spoofed. The email that contains the public key can also be spoofed. Okay, so how can Vincent be sure that the public key that he gets is the actual public key? It's a trick question. How about me handing him a thumb drive in class with the public key file? Okay, well, that should be fairly secure, unless there's a pretender, someone who can pretend to be me. until that technology matures, I'm pretty sure that that is one of the many ways that you can be sure that the key that you're getting is coming from that particular person. So is that okay? Whatever that the steps that I have written on the whiteboard. Okay, all right. And by the way, this is also how SSL certificates work. Okay, it is also based on key pair encryption, and this is also how you can be sure that the a particular website is that website when you use HTTPS, because there's a you are given the public key of the certificate, and the digest is encrypted using the private key. So you can basically decipher it on your end to make sure that the checksum is matching. All right. Well, that's pretty quick. We're done with this part. Generating a key pair. The first step to use GPG is to generate a key pair, and you can use this little command here on the command line to do that. Okay, it doesn't seem like much, it doesn't seem very difficult, but it is a little bit difficult. Okay, so we'll go ahead and take a look at the various steps of this particular command. The first the first question it will ask you is the key type. I'm not an encryption expert, so I'm not really that well versed on all of these options. I only know that the default is well established, so unless there are specific reasons why not to use this default, I think that is going to be okay. Next step is the key size. The length of the key determines the strength of a key pair. So that means the longer the key size, the more secure, the less likely, the more difficult it is for somebody to crack your key pair. But what is the downside of choosing a key size that is like really, really long? Speed, okay, because your recipient or whoever needs to decipher, or whenever you need to encrypt something, it will take a much longer time if you have a longer encryption key. It will also take longer to generate a key pair with a longer longer length of when you talk about the keys. You can specify a key up to 4096 bits. Now this is back when I first wrote this note here. That might have changed now. I think it is still 4096. The generation of a longer key takes significantly longer, but the application of a longer key also degrades linearly relative to the length of a key. So the longer the key, the more time it takes in order to decipher the content. But that part is only linear, which means if a key is double in size, it will just take twice as long to decipher it. In order to generate a key, on the other hand, is not linear. If you double the size of a key, it is not just taking twice as long to generate the key pair. It will actually take significantly much longer than that. The exact ratio, I'm not 100% sure, but I know it is not just linear. It is super linear. And then for all practical purposes, 2048-bit is sufficient for most applications. Again, I wrote this maybe 2-3 years ago. So whether processing power is now up to the point where 2048-bit for encryption is no longer sufficient, I don't know. Does anyone know what is the current standard of quote unquote default length of encryption keys? Nobody knows? Okay. I can see someone is looking right away. But that's okay. Expiration date. You can optionally specify when the key is going to expire. Now, there's a plus to specify an expiration date, and there's also a plus not to specify an expiration date. If you specify an expiration date, then when the key expires, you will have to redistribute a new key pair, okay? And you have to kind of keep doing it all the time. So unless you have an automated way to redistribute a key after the original one is expired, it will just be a hassle to everybody. Because remember, when you change the key pair, everybody who wants to send you email would also have to update their key chain so that your public key your new public key is updated in the key chain or the key ring. Yeah.
Is the key ring, is that generally where your system looks for the public and private keys.
Yeah, a key ring is just an organizer, so you can organize mostly the public keys of somebody else. You probably don't want to use the same keychain to maintain your own private key. You want to kind of put it somewhere safe. Okay. The GPG will also ask you for your user ID, but this is not the same UID as your usual UID, the Linux UID. With this user ID, it is really just a name. Okay, so the first component of the user ID is really just your normal name. So Alan Turing, which is the father of computer science, is okay as a given name. You also have to specify your email address, which is easy for people to identify. Okay, if anything happens, how do I contact you? This is how you can identify yourself. When you apply GPG, this is how you can also identify other people that you want to encrypt documents to, is to use their email address. So if I want to send an email to Vincent, I would look up his email address, and then I would say, okay, use the public key of this user to encrypt this document. So you probably want this to be a valid email address, but for testing purposes, if you specify some fake email address, nothing bad is going to happen. It's just that when you actually want to use GPG for practical purposes, you want to supply a valid email address as a part of the user ID. There's a comment field as a part of the user ID. It is not useful for searching purposes, but it is useful for commenting and documentation purposes. And this particular field is optional. Okay, this part is also optional. And it depends on how you want to do things. You can specify an optional passphrase associated with your GPG key pair. Okay. Now, if you specify a passphrase, that means every time you want to decrypt something using this key, using the private key, you will have to manually enter your password. Okay? There's no automated way that I know of that can enter the password automatically, which kind of defeats the whole purpose of having a password to begin with, right? So if you want to use GPG for automated tasks, you don't want to specify a passphrase, because then it cannot be automated anymore, because you have to be there to enter the password. On the other hand, if you want to make sure that in the event that you lose your private key, for whatever reason, you have a secondary line of defense, then you want to specify a passphrase, because in that case, just in case someone for whatever reason gets a hold of your private key, which is just a file, okay, that person will still need to enter your passphrase in order to get to the actual private key itself. So it's a secondary line of defense. It is useful. It's not useful. However, if you want to use GPG for any automated task, then you should not specify a passphrase. It is optional. Are there any questions about the passphrase part of a GPG key pair? Questions? Moving right along.
I've got one. So if
Go
your
ahead.
private key is compromised, is that just to buy you time to change things? Because you obviously wouldn't want to leave it out there just banking
Correct.
and take a crack your passphrase.
Well, I'm not sure how strong the passphrase is. Okay, in other words, can they brute force through a passphrase protected private key? The answer is probably yes. The question is, how long would it take to crack it? And I have no idea whether it's relatively strong, or really strong. But it definitely buys you extra time, in case you lose the file itself. Next, where are the key files actually stored? Because the command does not specify. You can specify options, but it really doesn't by default tell you where it's going to be stored. The key files by default are all going to be stored in the home folder. This is the tilde symbol, which is shift backtick. Backtick is the key at the upper left-hand corner of your keyboard. So if you press a shift and then a key, that becomes the tilde symbol. It is representing the home folder or the home directory. So under the home directory, you have what we call a hidden file in Linux, because any file name that starts with a dot, a period, is called a hidden file. and the directory name is called GNUPG in this case. The permissions are automatically set to D, RWX, and then all dashes after that. For those of you who read the notes from last Thursday or have a photographic memory from last Thursday, what does that mean with this type of flags? What does the D represent? Delete me? No. Directory, okay. And R means read, write, execute. But which user does it apply to?
The owner.
Say again?
The owner.
The user owner. The next 3 dashes apply to the group owner, and then the last 3 dashes correspond to others. Exactly. Okay, very good. So that means by default, this folder is protected from everybody else. Whether you protect your home folder, doesn't matter. This subfolder in your home folder is protected. Okay? So by default, it's put at a fairly safe place. Is it safe from root? Nothing is safe from root. Okay? So if you are doing anything on a server where somebody else is the administrator, keep that in mind. Okay? If you generate your GPG key pair on that particular computer, the root user can get to it. Okay? Of the files in this folder, the most important one is the one that you have to guard. Is called secring.gpg. This is your private key. The other one is called public ring.gpg. It is basically a key ring to store public keys, and that one, it's not really as important. I mean, if somebody gets a hold of your public key ring, it's not really the best thing to happen, but at the same time, it's not nearly as bad as having your private key ring to be stolen. Are there any questions about this portion? No questions? All right. If there are no questions about this portion, let me see if I can run this here, just as an example. Okay. So let me see if GPG is already installed. It is installed. Okay. And I'm gonna interrupt it. And what I'll do is I'm going to remove anything that I have in that folder already. I'm going to start from the beginning so you can actually see how this process works. So I will go all the way up and go to the first step, which is to run this command here. So I'm going to run gpg-gen key for key generation. And the first part is it will detect that I do not have a .GNU-PG folder, and it will create that directory first, and then once it's created, it will also put in the configuration file and all the other files that has to be there. But at this point, there's no key associated with the files. They're all basically empty files at this point. And the first part is, okay, what do I want to use as the, what kind of key do I want? And the option is, the default is number 1, but most people, or most documents that I have read recommends the second one. I guess nobody can trust RSA these days. Have you guys heard about the RSA? The RSA and the NSA and all the intricate details between those two? No? You guys have not heard? Okay. Maybe you should read some news first, or used to be news. Okay. NSA leaks. That will do it. Okay, I'm just going to magnify because that's easier to read. Background: the NSA, the National something agency. National Security Agency is the USA's signals intelligence agency and the biggest of the country's myriad of intelligence organizations. It has a strict focus on overseas rather than domestic surveillance. It is the phone and internet interception specialist of the USA and is responsible for code breaking. But the key is it's supposed to be working on foreign transmissions only. The story in a nutshell. A number of mass surveillance programs undertaken by the NSA and GCHQ, which is the British equivalent of the same kind of organizations. The agencies are able to access information stored by major US technology companies, and I'm not going to name any companies, but I think most people know what companies are involved in this case. It will be companies involved in making or publishing operating systems, right? Because operating systems, can have access to the files stored in file systems under that operating system. It would be companies making encryption, tools, companies making key pair, basically key rings and stuff like that. So those would be the U.S. technology companies that this particular sentence is referring to, often without individual warrants, as well as mass interpreting data from the fiber optic cable, which makes up the backbone of global phone and internet networks. The agencies also have worked to undermine the security standards upon which the internet commerce and banking relies. Okay, the last sentence should concern all of us. The first part is like, well, we are not, in a foreign country, we are not foreign spies, so we don't really have too much to concern about that. But do you do online banking? Do you use the internet? And do you need privacy? Well, if the answers are all yes in those cases, then we should all get concerned. Because what the NSA did was this is at least the claim. The claim was the NSA intentionally put into loopholes into the encryption mechanisms that it is publishing and recommending everybody else to follow. And why do you think the NSA is interested in putting a flaw basically into a recommended encryption scheme?
So they can break it.
Yep, exactly. So it's basically a back door in a way, so that the NSA would have the method to break any type of encrypted transmission. Now, since we are here, we might as well go for another digression. The other digression has to do with the guy who started one of the many, but this one is one of the bigger ones, antivirus software companies. McAfee, exactly. Okay, so McAfee was enough. He was in an interview, and he basically told everybody that he wanted to sell devices to create a dark internet. In other words, transmissions using that particular sub-network cannot be easily cracked by the U.S. government. Okay, so I want the dark web. There we go. That may not be it. He was trying to make some devices. This may be it. It reminds me of a certain character in Marvel. A technology guy who has lots of money. Tony Stark. He, in some way, he's kind of like that too. If you read, his, stories about him, he definitely has some resemblance to Tony Stark. He basically, wrote the antivirus program, in the early days, and he sold the company for a lot of money. And he talks about, how he used, all that money. If you read this part here, Okay, I'm gonna magnify this part. I know it has nothing to do with Linux security, but it's kind of interesting. It certainly is very entertaining, this part here. But he was also telling people that he basically knew there was a loophole in the NSA recommended encryption mechanism. So basically he knew about that, and he was ready to sell devices that uses a different encryption scheme, a more secure encryption scheme, so that when people want to share files, the encrypted traffic cannot be cracked by the U.S. government anymore. So that's basically the storyline of what he was about to do. But I have not heard of any follow up on that. Maybe the NSA contact called him up and tell him something. But I have no idea. I have no idea what happened at that point. He also got into some trouble because he was living overseas, and the story went like his neighbor's dog was barking and annoying him, and then one day that dog was, or the neighbor, I think the neighbor was shot, was killed, and he was arrested for suspicion of murder. Well, you have to read up on all that gossip stuff on him, but he is certainly a source of all kinds of gossips, and he self admits to like a majority of the gossips about him. So certainly an interesting character, and you would not. It's good to read through all his stuff, because some of that stuff is actually pretty on the money. I mean, the guy knows his stuff, despite all the drugs that he has taken. So you might want to read up on him, because he actually did know something about the NSA before this was before this blew up, basically. All right, getting back to where we were. Encryption key. There we go. Okay, so we'll pick two, so that we are not using anything that the RSA is recommended. It can be between 1024 and 3072, so it's no longer 4096. It used to be 4096, so it's not letting us use like super duper strong encryption anymore. And I'm pretty sure this was a change, because I remember in the past it was up to 4096, and now it's only up to 3072. All right, but the default is still 2048, so I'm going to take the default here. And then now it's asking me about expiration. So I can specify 0, which is the default of not expiring, or I can specify the expiration date of this particular key. So I'm going to take the default of not having this key to expire. Key does not expire at all. Is this correct? The default is N, which is no, that's why it's in uppercase. So if you want to confirm, you have to type Y and then press the Enter key. And now it's asking me for a user ID to identify my key. So this will be used if you want to publish your public key. GPG has a special mode to export your public key to somebody else. So it will include all the ID information that you enter here. So you better be careful with what you type here. So what I want to do here is to specify my name, and in that this part here specify my email address. I can always specify my 2014 spring email address. That. Nope.
They ask for your email later. Yeah.
Say again?
They ask for your email after this.
Oh. Okay. A real name. The email address is drtag2014spring@gmail.com, and comments is only good for 2014 spring. All right, and then I can either change name, comment, email, or say OK to accept it. So I'm going to specify OK, accept it, and this is where I can optionally enter a passphrase to protect my secret key. As I said a little bit earlier, if I type something here, then every time I try to use my private key, it will ask me for the passphrase. Okay, so I'm not going to enter anything here, because I do want to show you how to use GPG for certain things they can automate. Okay, press the Enter key. This part is interesting because not enough random bytes available. Not enough random bytes available. Please do some other work to give the OS a chance to collect more entropy. Okay, that means if I'm not doing anything, it's too predictable. It cannot come up with random numbers that are random enough. Okay, so it wants me to move the mouse a little bit, click, do other things. I know what I need to do. Go to games. That usually helps. Free Dink or Free Craft. Free Craft. It's basically Warcraft, the original Warcraft, but it's basically open sourced. So let's check the prompt here. It's still not convinced. All right. Single player mode. Start game.
It's the team creator.
Sorry?
I thought it was the team creator. The game.
Oh. Yep, that's the original Warcraft.
Oh, it is.
Yeah. Or at least based on the original Warcraft. And it's still not enough.
Is there anybody online?
Hmm?
Is there anybody online? There you go.
Alright, there we go. So I have to stop my game. Oh.
So is it based on CPU processing, or is it based on CPU usage?
It's not based on CPU usage, it's based on entropy. In other words, it wants things that are unpredictable. Exactly where it's getting the quote-unquote random number sequence, I'm not 100% sure. I don't think it's getting it from /def/urand because that's a character device, but I think it's using something else, and it has some kind of criteria to determine that okay, things are not random enough. You got to do something to introduce more randomness into the system. So now I have everything already done. So let's see whether that folder is here, and you can see I have lots of files here, but there's no .gnupg because, as I said, any file that starts with a dot is quote-unquote hidden. In other words, if you just do a ls, it's not going to show up. You have to say ls-a for the files starting with a dot to show up. So if I do a -a, then all kinds of files will show up. Okay, there are tons of files with a dot. So I can do ls-a dot GNU PG, and now I can actually see the content of the file. Are there any questions? Now, just to relate this topic to what we talked about on last Thursday, let's check. So I'm going to use ALD for accessing a hidden file. Make it long. I want to look at the details, and I want to look at the details of the directory itself, not files inside the directory. So that's why I use -ALD in this case, and then specify the folder name, and I can just confirm that what I said a little bit earlier was true. Okay, this directory is protected from everybody else, except for root, of course. All right, so let's go into that folder and find out what exactly are in those particular files. But before we do that, let's do another -L, just so that we can see the protection level of all of those files, and you can see that each individual file is also set up to have the maximum protection from group users and also from other users. Okay. Are there any questions at this point? Yep.
Are all those files generated in the initial generation?
Yes.
Right.
Yes, all of these are generated when I ran the command. All right. Well, this is all cool. In other words, we now have a key pair. The next question is, how do we do the encryption? Okay, which is in section 5, it's pretty easy. You just have to use a -E to say, I want you to do some encryption, and then the less than symbol and the greater than symbol, those are called redirection symbols. In other words, instead of reading the file to encrypt from the keyboard, I'm redirecting the file from test.txt as a file. Instead of printing the encrypted version onto the console, which is useless, right? It just displays a bunch of mumbo jumbo on my screen. I want to capture that output using the greater than symbol into test.txt.encrypted. So this is how you make use of GPG as a tool. Well, let's give it a spin and see if it works. Okay, so here I can find a particular file to encrypt, and let's see. Well, do you guys want to encrypt a fairly large file or small file? Because I can time it and see how long it takes to encrypt a relatively large file. Let's encrypt one of those class recording files. Okay, each one is about 1.6 gigabytes, so it's a pretty good size. We want to see how long it takes to encrypt 1.6 gigabytes using GPG. So GPG-E, and later on it will ask you, you're encrypting it using the public key of whom, okay? because GPG can keep track of a keyring. In other words, I can add a keyring from you guys into my keyring, and then I can say, oh, I want to send Vincent an email, and I want to encrypt the content. Okay, encrypt using Vincent's public key. So then the content becomes encrypted, and then Vincent will have the private key to decipher the message. Or I can do it to multiple people. I can basically say encrypt this document using the public keys of these following individuals, blah, 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 like that. Okay, and the generated file would actually understand that it has multiple encryption, done to the file, and then depending on who you are, it will pick out. You can specify the decryption key, and it will decipher the content, based on your private key. All right, so we'll do a -E here, and I will let it ask me, who I want to send it to later on, and we'll redirect from today's lecture in the morning. Let's say the 10:30 lecture that I have, and then just redirect it to lecture.flv encrypted, like that. The file extension is entirely up to you. Linux doesn't really care about file extensions. And we'll go ahead. Oh, here's another command that can be useful. It's simply called time. Okay, when you type time in Linux, it is telling the shell to give you statistics. How much processing time that the user process is taking, how much processing time the system is taking, and so on and so forth. Okay, so time is not really exactly a command. If you want to know the current time, that command is called date. Okay, so date and time, even though the name seems to be related, they do entirely different things. Okay, so we'll just press the enter key, and this is when it's asking, okay, I can see that you want to encrypt this file, but who is supposed to be the recipient? In other words, it wants me to specify the email address or the other ID of the recipient or recipients. In this case, it can be plural. You can specify more than one. In this case, I'm going to use my email address, which is Dr. Tech 2014 spring@gmail.com, which is one way to identify myself. Press the enter key, and I can add additional recipients, but I don't have any I don't have the public key of anyone else in my keyring, so there's really nothing I can do at this point. So I just press the enter key, end with an empty line, and now it's actually doing it. We'll see whether it can get it done in 15 minutes, because I really think that it may not be able to get it done in 15 minutes. All right, so the other form is to use it like this. If you don't want it to ask you about the recipient, you can basically use the -R option to specify the recipient on the same command line, so it doesn't have the interactive portion of saying, okay, who do you want to encrypt this message to or encrypt this file to? You can just specify a long list of recipients using the -R option. Now, if you have any questions about how to use GPG, you can also use the man page of GPG, assuming the document is installed, and just learn all of the options here. Okay, there's a gazillion options with GPG, and many of those are pretty useful. Are there any questions about GPG up to this point? So at this point, we are just encrypting a file, okay, after you specify who's supposed to receive it. All right. Yep.
Do multiple levels of encryption provide any more protection?
Like encrypting an encrypted file?
Yeah. Like if I do encrypted files in an encrypted container.
If the encryption key is of the same strength, then if they can crack one level, they will be able to crack the other levels as well. So that will just be linear in terms of time. In other words, if you have a triple encrypted file, it will take, quote unquote, 3 times as long to get to the actual content.
But if I use if one of those levels had a weaker encryption, is it only as strong as the weakest link?
You can probably make the assumption that if the strongest one can be cracked, then the easier ones would not be a problem. Okay. Any other questions? Okay. Other questions?
Would it be a good idea to encrypt via different means, just like use different different algorithms just so that
And use one that is really stupid just to throw it off, right?
Yeah.
All right. Well, this is for deciphering. To decipher is pretty much the same thing, except you give it the encrypted version, and then you specify -D instead of -E. In this case, when it's deciphering, if the file is encrypted for multiple recipients, you will have to identify yourself, like, okay, I am so-and-so, and use my private key to decipher the content of this file. Are there any questions at this point? Well, I have a question. Where am I supposed to store my private key? Because I might need to use my private key when I'm at work, at school, and also at home. So where am I going to put my private key? The public key is not a problem. I can put it on my website. Yep, go ahead. Oh.
Thumb drive?
Thumb drive. Okay. So as soon as you plug in your thumb drive to a computer, what happens? You better make sure that you know who owns that computer and whether the owner or the administrator of that computer would do something funny with files on your thumb drive. Does that make any sense? Because as soon as you plug in a thumb drive that contains your private key, whoever is operating that computer, whether it's automated or not, can now see the content of your thumb drive. When they see the content of your thumb drive and it contains the private key of encryption, then your private key is now, quote unquote, open and accessible to other people. Is that okay?
It's not private.
And it's not so private anymore, exactly. So it makes no sense, to me at least, it makes no sense whatsoever to apply, to use GPG and use the private key on a computer that is not secure itself. Is that making any sense? So you go to a hotel room, okay, and you say, okay, it's time to send an encrypted message to somebody, okay? So you basically, in that case, it's okay, because if you are sending the message, why is that okay? If I'm sending a message to, let's say, Derek Booth, the dean, why is it okay to use any computer? A public computer is fine. Sorry? Exactly. There's no private key involved when I'm not the recipient. Okay? I only need the private key when I'm deciphering content that is sent to me. Okay? So here's the question: you're at a hotel, expecting someone to send you an encrypted message. What are you gonna do? You are allowed to bring anything you want, but you're in a hotel room, and the hotel room computer is the one that is internet connected. So what are you gonna do?
Bring your laptop.
Bring your laptop. Exactly. It is as simple as that. Okay. Bring your laptop computer. Download a file from the hotel room computer onto a thumb drive or whatever, and then do all the deciphering on your own computer. Okay? Do not do it, using a computer at a library, for instance. Okay? Do not do it at our own library here. Okay? I don't think anyone here really know enough to grab private keys as soon as you plug in your thumb drive, but still, okay, as a practice, don't do that. Should you put it on your Android phone? Why not? We talked about this before. So why would you not put your private key for keypad encryption on your phone? It is so handy.
So how do you get around the problem, like on SSH, if you have a server that is not set up to accept passwords, it's only key pairs.
Right.
And you go to a remote location, you need to get to that server, and you need your key. How do you keep that?
That's a tough one. That really is a tough one. Okay, I know the answer to that one. SSH, along with many other type of encryption schemes, can use one-time passwords, OTPs. So with OTPs, it's okay because that password is only good for a certain amount of time, or it's only good for one use. So after that one use, you cannot use the same password anymore. So they can capture all they want. Whatever you type on the keyboard is useless because you cannot use that same password again. So the answer to that question is OTP, one-time passwords. And I know that SSH can deal with OTPs, so that's going to be useful for what you just talked about. Yep.
Did you also do your own boot from the hard drive? Encrypted drive?
Your own boot from the hard drive will give you a certain degree of security, but there are two problems with that. One is the hotel may lock down the computers, so you cannot boot with any type of a removable media. And then the second thing is, if the hotel is really involved in getting your stuff, they can have hardware key loggers that are not on the outside but the inside of the case. So then you have to open the case and make sure there's no chips attached to the USB bus, because it's easy to do that. Because what you see on the back of a computer, all these USB jacks, they are basically connections or connected to a internal hub. And most motherboards have a 10-pin header. Not 10-pin, excuse me, I take it back, not 10-pin, but they have a header on the motherboard that allows you to tap to the same USB hub, but from inside the case. Now, that is done so that you can hook up to SD card readers, that are quote-unquote internal. So for aesthetics purposes, you can make it look nice and not have all kinds of wires running around. But if someone attaches, a sniffing device, to sniff, the traffic on the USB board, then you're shot. So when you're using somebody else's computer, they can always go through some extreme measures to get to whatever you're typing, and whatever you do on the screen can be captured. Am I paranoid? No, I don't think so. I'm just saying that what can happen, right? All right, so let's see here. The encryption is all done. Oh, this is telling us exactly how much time it takes. It's telling us that this is real time. In other words, it actually took about 3 minutes altogether to encrypt that file. Out of those 3 minutes, the user itself, this is actually not referring to the user, but user space, time. It is 1 minute and 50 seconds, and then the system itself took another 2 seconds or so. So the 2 seconds used by the system is probably just for file I/O operations, because file I/O operations are implemented or supported by the kernel and not by your own process. And then the other amount of time of user is actually the time spent to actually do the processing, mostly to do the encryption. So it spent about 1 minute and 50 seconds, close to 3 minutes, to encrypt about 1.6 gigabytes of material. Not bad at all. I would not call that inefficient. I would call that pretty good. Any questions about this? So if you figure it's about 1 minute per gigabyte, with this particular computer, which is not bad. I mean, that's reasonable. So let's go ahead and decrypt that file. So we'll go ahead and use GPG-D for decryption, and specify lecture.flv.encrypted. And I really don't need to store it anywhere, so I'll just dump it to a black hole in this case, and we'll time it, see how long it takes to do the deciphering. It knows that I am, who I am, because my private key is stored in GNU PG, the subdirectory. Okay. On the other hand, if secrain.gpg is not stored in that folder, then it will have to ask me and say, well, but who are you? Where's your private key? But since it's already stored in that folder, it doesn't need to ask me. So we'll see how long this takes, and compare the encryption time versus the deciphering time. Okay, see how that compares. And while this is working, we'll go ahead and finish some more of this material. This is just basically what we talked about, how you really need to spend some time to think about how to protect your private key file, the secrain.gpg file. And how to apply GPG. This particular slide talks about making sure that there's no hardware or software key logging, okay? Because once you have key logging and also capturing the file, then your private key and also your passphrase can be captured. Nifty command line combos. Okay. So this is combining two commands into one. The first command is using tar. Tar stands for tape archive. So the original purpose of tar is really for backing up files in a folder onto tape. Okay, but the nice thing about tar is it creates a single file out of folders and individual files. It's kind of like zip, okay, except this is coming from the Unix/Linux environment, whereas zip is more traditionally associated with Windows. So tar would create a single file, but in this case the single file is dash, which means it's standard output, which also means this command by itself normally would generate its output and stash it and just pump it onto the screen. A whole bunch of gibberish will appear on the screen, which is not useful, right? So what I do is I use the pipe operator. This is not the greater than symbol. This is called the vertical bar symbol. The vertical bar symbol is called the pipe symbol. It serves a similar but different purpose compared to the greater than symbol. The greater than symbol is redirecting to a file. In other words, send all the output of this particular command and capture all of that into a file. This one says take all the output of this particular command and make it the input to the second command. Okay, so in this case, the second command is this part here. This is my second command. So what the first command is basically just a way to look at a folder, a whole bunch of files, whatever that you want to encrypt, and generate one single stream out of all of those files or folders. Feed it to GPG for encryption purposes. And then GPG itself has the redirect output symbol, the greater than symbol. So now you can basically, using one single line, you can have two commands in order to archive and encrypt, archive, compress, and encrypt into a single file representing the folder that you're backing up. Are there any questions about this particular command? Now you can also chain this even more. I think the next slide actually talks about this one. No, it does not. This one is just doing it in reverse. You start with a folder that is tar gzipped and encrypted, and feed it through GPG-D first to decipher the content, and then you feed the output, which is the deciphered tar file, through tar to decipher, to basically expand all the files and folders back up again. Okay. But I do want to point out one thing. You can change some more stuff after this. Okay, you can have another pipe symbol and then pipe it to SSH. Okay, now SSH is useful because most people think about SSH and say, oh, that's just a more secure version of Telnet. Well, you can use it for that purpose. It's a very common use of SSH to remotely remote into a system and run commands. But you can also use it to transmit information. In other words, you can take the output of, in this case, GPG-E, the encrypted version of that file, and then use SSH to directly transport that file to another system for backup purposes. So as far as the other system is concerned, it can only see the encrypted version of the file. It has no access to the original form of whatever you're backing up. Which means if someone breaks into the backup server, all they can see, all they can steal would be the encrypted file and nothing else. So that's a relatively safe way to do a backup, is to, instead of using a redirection here to a file, you use a pipe symbol and use SSH to directly transfer that file to another computer. Are there any questions at this point about GPG? No questions? Yep, go ahead.
Is it pretty secure? Considered?
I would say so. I would say GPG is pretty secure. I have not heard of anything regarding it being insecure, but if you look for GPG insecure, we can see what we can dig up. Okay, so apparently using insecure memory is one of the things that GPG itself can complain about. Oh, okay. On many systems, the program should be installed as SUID root. This is necessary to lock memory pages, because what happens is if GPG itself requires paging, which means it has to save some of its memory content when the program is running onto the disk, then if the swap file itself is not encrypted, then everybody can basically look at it. Okay, well, not everybody, but someone who can reboot your system, or someone who has access to that particular partition can now read the swap file itself, and then the content in the swap file would not be encrypted. So that's what it's complaining about. This is basically all that is. At least that's what's coming up. Okay, let's do a dash memory, which means we look for GPG insecure, but without memory in the key, using multiple subkeys. Nope. So no one has, apparently there are no complaints about GPG being insecure inherently. I mean, you can always do things to make it insecure, on the user's part, but as far as the tool is concerned, there's no complaint that I can find. Or at least, Google could not find anything. Right? So you can probably expect your next homework assignment to be revolving around GPG. And then we are not done with GPG yet, okay? Because with GPG, the next topic is how can you establish what we call a web of trust, okay? In other words, how do you know that I am me, okay? What if you tell him that I am me, and he is trusting you, and you're trusting me, so now he can trust me.
My brain is done for the day.
Done for the day, okay. But that's basically what you can do with GPG, is you can establish what we call a web of trust. So in place of a CA, a certificate authority, as a centralized place to establish the authenticity of everybody, now you can basically have one person as a referral to another person, and then you have what they call a web of trust. Okay, so we'll talk about that next on Thursday. Yep. Oh, no. I'll make it after the spring break. Okay. Nope. Okay, so do you need to burn that image onto your media so that you can start a computer using your flash drive or SD card?
I don't have a computer to do that on. They don't boot CD in the lab.
Okay. That would be a problem. Well, in the lab, you can use. Do they have VirtualBox installed?
They do have VirtualBox, but I'm gonna have to reset up everything every time I go in.
You don't have to, because you can direct VirtualBox to a file on your external hard drive or jump drive.
Does it save as a virtual drive?
Yeah. So you basically take all the virtual drive, everything onto your removable media, and then every time you start VirtualBox, you tell VirtualBox where to find your stuff. That works.
Only problem I have with that is that if I don't get the homework done in time during lab hours, then I'm not going to be able to get the homework done anywhere else.
Well, you have to do it in the lab, but you can suspend the virtual machine so you can resume it when you come back, at a later time. So you can still get your homework done. It's just that if you cannot do it in one single session, you will have to break it up into multiple sessions. But you don't have to restart from the beginning. You don't have to start from scratch.
Okay, well, what do I do about the one for installing Linux, since I'm obviously not going to be able to complete that one?
Okay. What I can do, at least for now, is I can duck some points after the fact, but at least I can reopen that so you can finish that one. Because if you don't finish that one, you cannot do the other ones. So I do have to give you the time, to finish that one at least.
Okay, I'll do it. Tomorrow is the day I'm supposed to be on standby for jury duty. Still, they got me in a holding pattern. So. You got it too?
I have to check on the second.
I'm waiting.